I'm Veronica Wright, and we're at CES 2024 with Texas Instruments at their renewable energy booth. This looks like a completely electrified home. Errol, what are we having here?
No, thanks for having me. Yeah, good question here. So what we have actually here is showing from the grid all the way to the electric vehicle, and all those different steps that you need in order to transition or translate energy from either storing it or converting it to either go back to the grid, or even if you were to have it for charging a car at that point.
How does semiconductor technology actually enable all this?
Oh yes. So we have an array of devices, right, that are very helpful within all these spaces. Some examples of that would be, for example, the metering. Metering, you need high accuracy in order to do that based off the standards. So we have different devices in the signal chain side, from like ADCs to have high precision there, as well as like our MCU, like our MSP M0 line, to do all the calculations to calculate energy within a really high accuracy. As we go into conversion as well, that's another area where we have like our gate drivers, our real-time controllers to do those high voltage conversions, and then distribute that load over to something like either storing it, where then we have our battery management devices, or putting it out to something else like a vehicle, where then you have like, your EV charging, and those are where we have a very wide variety of products as well for flexibility there.
Yes, I think it's really, really exciting times as you show here, a solar system connecting to your house, energy stored in a battery energy storage system. You can then charge your EV from it. So maybe we can talk a little bit more about the details of some of these parts.
Oh yes. Yes, exactly. So I think we'll start here really quick. So since we're right here, so over here I would say we have different processors, such as our AM62 device. It's a really good processor. It's a Linux-based core, A53 core that is very flexible. It's able to do all the communications that are within the new standards in the new cars that are coming out, such as like the ISO 15118, which then enables smart features like vehicle to grid.
Yes, that's very exciting.
Exactly. And then a bunch of analog circuitry here as well, as you can see down here, for some of like the power monitoring and conversions to power everything, and even like protection as well.
What about the string inverter? You mentioned that before.
Yes. So if we go over to string inverter, right, this is where we'd have our real-time controllers for conversion, such as our C2000 line. Those would actually do like, the PWM signals, right, to then switch like the different transistors, such as like the silicon carbide ones, to do that sort of translation. And then in addition to that, you're going to need some sort of measurements for accuracy for current to measure for feedback, in order to get like, the high efficiencies and accuracy.
Yes.
So that's where we have like, our Hall effect line. That's actually one of our new devices, our TMCS devices, like the 1123 series that's, out on TI.com. Those are high precision Hall effect devices that can measure with really good accuracy.
I think this is just really a great example of so many different devices coming together. What's next in this area?
Good question there. I think next would be almost like the management side of things, right? As you start seeing all these different areas, how do you effectively manage the power between all of them and optimize it, for whether that's from like a cost perspective or from an efficiency perspective. So this is where I think you're going to see certain things of all this connectivity in place, and that's going to be like wireless. That's probably going to be in play, like Ethernet, all those different sorts of like gateways.
That's very, very exciting. Thank you so much. And if you want to have more information, go check it out at ti.com/CES.